Hey, look right at the screen you're holding right now. You might think you're just casually watching an explainer, but what you are actually doing is staring directly into a highly engineered, concentrated beam of electromagnetic radiation. Welcome to the secret of light, the science controlling your life.
Now, you might be wondering why everything is styled in this super vibrant shade of green. Well, it's pure science. 555 nanometers. That is the exact wavelength of green light where the human eye's visual sensitivity absolutely peaks. We've optimized this visual experience perfectly for your biology, making it as easy and engaging for your eyes as possible. And really, it's a perfect example of what we're going to uncover today. How light isn't just something that helps us see, it's an actual physical force that interacts with our bodies in some profoundly specific ways.
Okay, let's dive into this. Section 1, the physical mystery of light. So for the longest time, the exact nature of light literally stumps scientists. It behaves in ways that seem entirely contradictory depending on how you actually measure it. Take that white light coming from your screen right now. Actually, scratch that. It's not even white. Notice how a prism separates it into an entire electromagnetic spectrum, like a continuous rainbow of radiation, spanning all the way from violet to red. By treating light as a wave, scientists could suddenly calculate its continuous speed, predict how it reflects off a mirror, or how it refracts and bends through glass. But wave theory had a massive blind spot. It completely failed when it came to calculating the actual energy of radiation for different wavelengths. To solve that puzzle, we needed a completely different perspective. Back in the year 1900, a physicist named Max Planck assumed that the energy of radiation isn't a continuous wave at all. Instead, it's emitted in discrete, indivisible little portions. He called them quanta. For visible light, we call these discrete packets photons. So we end up with this really beautiful duality. Wave theory tells us how light travels and bends, but quantum theory tells us how it delivers its energy. And understanding that energy, that is what finally allowed humans to master it. Moving right along to Section 2, how we create light. Because once we understood the physics of light, we stopped just being passive observers and started manipulating the physics to create it ourselves. For almost all of human history, we relied on thermal radiators. We had the ultimate free source in nature with the sun, but when our ancestors wanted to engineer light, they had to use the exact same crude principle. They burned wood. Fire is just early thermal radiation, heating a material up so much that it basically begins to release energy as visible light. And this brilliantly illustrates our progress. Because for over a century, our brightest idea was still just a thermal radiator, the traditional incandescent glass bulb. We just ran electricity through a filament until it got so hot it glowed, wasting most of the energy as heat. Compare that to a modern LED setup, this colorful marvel that doesn't rely on extreme heat at all. We completely changed the game. Which brings us to Section 3, the LED technology revolution. So, stepping away from burning things and heating things meant entering the era of solid-state radiators. Here's the complex solid-state physics of an LED broken down into 3 super simple steps. First, we take semiconductor material and layer it into what's called a p-n junction. Basically, one side has an excess of electrons and the other side has missing electrons. We call those electron holes. When you apply a voltage across this junction, you literally push the electrons so they fall into those holes. As they drop from a high energy level down to a lower one, that exact energy difference is emitted as a photon of light. Pretty cool, right? Unlike a roaring fire or, electrified gas trapped into fragile tube, this modern light is generated purely within tiny, incredibly durable, solid materials. It's highly efficient, it's precisely controllable, and it completely sets the stage for our biggest revelation yet. Because with this incredible, unprecedented control over light, we inadvertently began messing with our own biology. All right, Section 4, light controls your biological clock. Okay, here's where the narrative twists. We've talked about physics and engineering, but now we really need to talk about you. We all know about the rods and cones in our eyes that help us see shapes and colors, sure, but there is a third, entirely different type of photoreceptor hidden in your eye. It's called the IPRGC, the intrinsic photosensitive retinal ganglion cell. These specific cells do not help you read words or see pictures. Instead, they have a direct nerve connection straight to the suprachiasmatic nuclei. That is the biological clock located deep inside your brain. So, the absolutely crucial point is this. Lighting doesn't just have a visual effect. It has a profound, non-visual biological effect. That clock in your brain has a direct nerve connection to your pineal gland, which regulates the hormones in your body, like melatonin. This means there is a hardwired physical connection between the light entering your eye, your bodily timing, and your hormones. Lighting isn't just about vision anymore, folks. It is fundamentally dictating your biological health. And here is the fascinating paradox of human biology. Remember at the very beginning of this explainer when I told you your eyes see green light best at 555 nanometers? Well, your biological clock operates on a totally different wavelength. Your non-visual biological sensitivity absolutely peaks in the blue region of the spectrum. Light with a high color temperature, that crisp, bluish-white light, is biologically far more effective at suppressing melatonin and telling your brain it is daytime than lower, warmer light. So what does this all mean for your daily life? Well, because we are constantly blasting ourselves with high-efficiency, blue-rich, solid-state LED light from our phones, laptops, and overhead fixtures long after the sun goes down, we are constantly confusing those IPRGC sensors. We are actively suppressing our melatonin at the exact time we should be producing it. This is exactly why crossing time zones gives you brutal jet lag, why shift work physically disrupts your health, and why nighttime screen exposure absolutely destroys your sleep quality. Your biology literally thinks it's still noon. Let's wrap things up with Section 5, the future of sustainable lighting. Now that we have the technological power to create light out of tiny solid chips and the biological knowledge of how that light actively alters our hormones, we've got a massive responsibility. We have to balance our physical need to see with the health of our bodies and, frankly, the health of our Earth. As early as 1972, the Club of Rome published the Limits to Growth report warning us all about resource depletion. Today, creating sustainable lighting means exactly this: maximizing our energy efficiency through advanced LEDs, eliminating hazardous substances like the mercury we used to use in old fluorescent tubes, and actively reducing light pollution. We have to balance the positive visual effects of our installations with their environmental footprint. Basically, it's about improving the quality of our modern lives without destroying the quality of the world we live in. From the quantum physics of Max Planck to the biological clock ticking right inside your brain, light is the invisible string tying your health to the universe. The screen you are looking at right now isn't just a tool for information. It is a radiant source of energy actively communicating with your nervous system. So I want to leave you with one final thought to reconsider as you go about your evening. Have you managed your light today?